Hello everyone and welcome to the next session of our Digital WeDays 2024. My name is eiSos and I will moderate this webinar today. We are very pleased that you took the time to participate in our webinar session. The topic of the day is the role of transformers in high voltage BMS up to 1500 volt. Our speaker today is Lamprecht, who is working as a product manager at Würth Elektronik eiSos. Samu, good morning. Hi.
Thank you.
Before we start with the webinar, I would like to give you some more information. First of all, you will be muted during the webinar. This means that you cannot ask us questions via your microphone, but you have the opportunity to ask your questions in the chat. Today's webinar will be about 30 minutes long, and after that we make a short Q&A session and Samu answered your questions. If you are unable to answer all your questions, Samuel will answer them via email in the next days. So last information from my side, you will all receive the link to the presentation as well as to the recording in the next days. So now I give it over to you, and I wish you an exciting webinar.
Yeah, so then also from my side, hello and welcome to this presentations on this year's Digital Days at WE with the topic the role of transformers in high voltage battery management systems for up to 1500 volts. As Silas said, my name is Samuel Lamprecht and I'm Junior Product Manager in the Product Management eiSos in Waldenburg. BMS stands for Battery Management System. We at Würth Elektronik eiSos supply, among other things, an important component, namely the BMS transformers. Today's presentation will focus on the necessity and the role of signal transformers in high voltage BMS, as mentioned, for up to 1500 volts. So let's firstly go short over today's agenda. So we will talk about current trends and challenges in the energy storage market, the necessity of battery management systems, specific challenges for transformers with high operating voltages. Then we will go over to the essential safety standards, the transformer solutions for isolations up to 1500 volts, and then we will end up with a short conclusion and an outlook. So let me start. The conversion of electric grids to renewable energies, especially for wind powers and photovoltaics, which are not always available, is fueling the needs for larger energy storage systems. Two key pillars of the energy transitions are the widespread use of wind power and photovoltaic systems. In principle, wind and sunshine are free and inexhaustible, meaning that these forms of energy can be used to generate electricity in a climate-friendly way. Unfortunately, there is one weakness. Both forms of energy are not continuously available and are suspect to major variabilities. Therefore, if we don't want the lights to go off when it's dark, we need either power plant capacity or buffer storage that can at least temporarily replace the energy missing from the power grid. The graphic on the left side shows the most common methods for storing electricity and energy in terms of storage duration and capacity. Advances in battery technologies are now making large battery systems increasingly attractive as buffer storage systems. These energy storage systems then have the task of balancing out the fluctuating energy supply and changing energy demands, as well as softening feed-in and consumption peaks. As can be seen in the diagram, battery storage systems are typically used for storage periods ranging from several minutes to several hours. So as you can see, here we have the typical thing. So the battery storage for more than some minutes, a few hours, up to 1 day. Of course, significantly shorter or longer storage periods can also occur in individual cases. To gain a better understanding of the current challenges on the electricity market, we take a closer look at current trends and challenges on the German market. In Germany, we are several current trends and challenges related to energy storage and the power grid. So for example, we see some trends in energy storage. So for example, a study from Frontier Economics confirms that the benefits of large-scale deployment of energy storage and associated flexibility for renewable energy systems are enormous. So for example, the storage capacity will grow rapidly to more than 60 gigawatt hours by 2030. The left graph, as we can see here on this side, shows an overview of expected rollout for large-scale energy storage systems in Germany. So we can see that the installed capacity will be growing a lot in the next 25 years. And all of the studies were explained in this graphic. So we see we have different ones, like 6 ones, and all shows that we see an increasing demand in here. So the demand for battery systems, especially for lithium-ion batteries, are increasing due to the falling costs and the growing needs for flexibility in our power system. There is also a trend to home battery storage systems in combination with, for example, solar panels to use the own produced energy. But also we see on the other hand side that we have some challenges in our power grid. So for example, the needed expansion of the power grid in Germany has proven from studies to be a difficult process afflicted by public resistance. Nevertheless, for now, the German power grid is one of the most reliable in the world. But there is a growing energy demand with larger peaks due to e-mobility and electric heat pumps. These peaks can be seen also in the right graph, where the average price development over a day with and without stationary battery storages are compared. So we can see that here, for example, for 2030, we see large peaks, and we see that without battery storages, the price development over a day will have a peak at round about 6 o'clock in the evening, for example, when the heat pumps and the electrical cars will be charged. And also we see that with more battery storage capacity, that until 2050 we will flatten down this curve so that we have not that high peaks in energy prices. So we see that there are consumption peaks, like I said, for example, when the people return home from the working and start, for example, charging their electric cars or consume more energy at home for the television, heating pumps, and so on. And yeah, as I explained, we also see how the energy prices will a little bit more stable over the day. So let's come to different BMS. The energy storage systems considered here typically work with electrochemical battery cells. There are various electrochemical battery cells that differ in their respective properties and areas of application. One prominent example is the widely used lithium-ion battery cells. Depending on the area of application, these systems can be differentiated according to their capacity and their performance. Different battery technologies and batteries with different capacities need specific battery management systems which are designed to handle the battery. It makes sense to divide batteries into 3 size ranges. So for example, we have 3 to 20 kilowatt hours for all home and small company storage systems. Then we have 20 kilowatt hours to 100 kilowatt hours for energy storage for communities and businesses. And also we have the largest one from 100 kilowatt hours to 5 megawatt hours or bigger, for example, for power suppliers and grid operators. Small and middle-sized energy storage systems often operate at lower working voltages, such as 600 volt. Larger energy storage systems, e.g. for energy suppliers and grid operators, operate at up to 1500 volts. These higher working voltages change the environments for electric components operating in the neighborhood and inside of these batteries. But firstly, let me explain the role of the BMS in electric-driven vehicles and energy storage systems. The BMS is an electronic system that controls and protects a rechargeable battery to guarantee its best performance, longevity and safety. It tracks the battery's conditions, generates secondary data and generates critical information reports. For example, the stage of charge, the SOC, or the state of health, the SOH, and residual capacity are three important metrics tracked and calculated by the BMS. Additionally, it monitors crucial variables like current, voltage, and temperature. The BMS actively guards the battery against risks like deep discharge, overcharging, overheating, and overcurrent conditions. It also regulates the environment of the battery by controlling the heating and cooling systems to keep the battery working within its ideal temperature range. Cell balancing is another crucial BMS function that ensures each cell in a battery pack charges and discharges uniformly, enhancing the battery's overall performance and durability. To conclude, the BMS functions as the battery pack's brain. In several ways, it makes judgments depending on the information it gathers, and these choices have an impact on the battery's performance and longevity. Without a BMS, a battery might be overcharged or over-discharged, both of which have the potential to shorten its lifespan and cause battery failures. So let's come to the BMS transformers and their role in the BMS. As you know, we have different signal transformers. These include, for example, LAN transformers, PLC transformers, and many others, such as BMS transformers. Transformers for battery management systems and normal signal transformers serve different purposes and therefore have different specifications. BMS transformers meet the requirements for BMS and are specifically designed for this application. The individual battery cell of the battery pack are connected in series, such as the BMS controllers. Voltage differences and electromechanical interference can occur between the components or circuit boards connected in series. Transformers can be used to isolate the components between the high voltage and low voltage sides and suppress EMI interference. This is particularly important to ensure that no dangerous voltages are transmitted to touchable parts or the BMS. The WE-BMS transformers fulfill this function and create BMS isolation and EMI interference suppression for safe and reliable operation. As I told, there are specific challenges for transformers with these high operating voltages. So let's look a bit around it. So signal transformers for high voltage have different challenges. Some examples are, for example, the isolation and safety. It is important to achieve a robust electrical isolation between the high voltage battery models for the safety. Signal transformers must maintain isolation even under extreme conditions. Also, we see that we have some challenges for creepage and clearance distances. High voltage systems require larger creepage and clearance distances to prevent arcing and ensure safety. Also, the size and the weight is a factor. So due to higher requirements, the high voltage parts normally are bigger and heavier. Also, we see a challenge for the frequency range. So signal transformers must handle wide bandwidths. There also could occur higher harmonics and transient responses by higher operating voltages. So in summary, we can say designing signal transformers for high voltage BMS involve addressing safety, accuracy, efficiency, and heat dissipation. Lower voltage systems benefit from simpler design, but may have less strict requirements. So let's look at the essential safety standards. In addition to the challenges described in before, there are two specific norms which are important for BMS signal transformers. These are, for example, the IEC 60664-1, which contains all relevant information regarding transformers, and also the IEC 62368-1, which contains information regarding audio-video information and communication technology equipment. These norms also refer to some other standards and norms, but these will not be discussed further in here. Important aspects in designing of a BMS transformers according to these norms are the creepage and clearance distances, as well as the selection of a suitable insulation for the wire. A distinction is made between functional, basic, supplementary and reinforced isolation. The different types of isolations can be seen in the left upper picture, so as you can see in here. Functional isolation is the minimum level requirement for functionality. However, this type of isolation does not prevent electrical shock. Basic insulation provides the user with simple protection against electrical shock. The supplementary isolation goes beyond this basic isolation and provides further protection. Reinforced isolation provides an additional layer that works in a similar way to the supplementary isolation. Even if the basic isolation fails, the supplementary isolation remains effective and protects the user. On the bottom side, you can see a partial discharge test, so here on the left side, which is a good test to test the isolation for working voltages. But I will come back later to this topic on one of the next slides. The clearance distance is the shortest distance between two conductors throughout the air. So as you can see, the clearance is here the marked one, and the creepage is the other one. So it's important to ensure sufficient clearance distances in order to protect people and systems from the effects of electrical operating voltages. The required clearance is determined by determining the overvoltage category, the degree of contamination, and the operating voltage. So the minimum clearance distance can then be determined using table 14 of the above mentioned standard. The creepage distance is the shortest distance along the surface of an isolating material between two conducting parts. The creepage distance is determined in a similar way than the clearance distance. By looking at the overvoltage category, the degree of contamination, and the working voltage, the minimum creepage distance can then be calculated using table 17 of the mentioned standard. So let's make a short overview of our product portfolio for BMS transformers. So since some years we have 6 different BMS transformers for applications up to 1000 volt. All of these BMS transformers, which are in our portfolio since several years, are designed for test voltages up to 4.3 kV for 60 seconds or 1000 volt continuously. As you can see in the schematics, we have transformers with middle pin and without it. So for example, on the left side we can see we have here a part with middle pin and a part without the middle pin. You can find information about this in 5-chip manuals from the IC companies. Normally, we recommend to use transformers with middle pins. Some IC companies argue to use transformers without middle pin because of a cheaper price. In fact, the prices are quite the same, so we always recommend to use the transformers with a middle pin. I would like to briefly reiterate these articles. All of the BMS transformers which are in a longer time in our portfolio are designed for working voltages up to 4300 volts and for working voltages of 1000 volt. They all have passed the tests for AEC-Q 200 and are proven for temperatures from -40 to +125 degrees. FIY 6 wire from a good known German wire company is used to achieve the high insulation voltages. The company develops and produces in Germany and is known worldwide for its extensive know-how of high quality enameled wires. One specialty is that they have high clearance and creepage distances, which are achieved through a special housing design. You can see this comparing to other products on the market in the shown picture. The main reason for this design is the mangan zinc core, which reduces the creepage and clearance distances. Therefore, we use the special design to get high physical creepage and clearance distances in a housing with small outer dimensions. As opposed in competitors, the required creepage distance is achieved without an additional coating exposed to ambient conditions such as dryness or heat. As can be seen in the picture on the left, our special housing design consists of two different parts, so we have an underlayer and an upper layer. But for sure, the final product is of course a single component. This is for illustration purpose only. But as transformers for working voltages up to 1000 volt are not the main part of this presentation, let us switch to our signal transformers for operating voltages up to 1500 volts. As of beginning of 2024, Würth Elektronik have 3 more BMS transformers with 1.5 kilovolts in the portfolios. The two articles on the left side, so 400 and 401, use a housing with the same dimension and have both signal transformers and a common mode choke integrated. The difference between the two articles is that one has a middle pin and center tabs in the transformers, and the left one doesn't. So for better common mode behavior, we also here recommend connecting the center pins to the ground. The left article, so 402, which is shown here on the right side, has a housing with different outer dimensions. The difference to the other ones is that this article has only one channel and the other two have 2 channels. So as you can see in the schematic for the parts, there are also transformers with and without a center pin. In addition to the integrated common mode choke in the transformer module, the center pin contributes to the suppression of common mode interference. For this purpose, a bypass capacitor is connected to the center pin, which provides a low impedance ground connection for common mode interference and thus diverts it towards the earth. This leads to an improvement in eiSos SPI performance. For the selection of the capacitors, please refer also here to the IC manufacturer's data sheets. All of our new BMS transformers are designed for test voltages up to 6400 volt DC or for working voltages of 1500 volts continuously, and are also approved for a temperature range from -40 to +125 degrees. The triple isolated wire, also from the same company as mentioned in before, achieves the high isolation voltages. Funny side fact from our side, so after we performed an ACQ temp cycle test with 1000 hours between changing temperatures from -40 to +125 degrees, we wanted to perform a high-pot test with 6.4 kilovolt DC for 60 seconds, but actually our lab used the wrong settings and tested 6.4 kV AC, which is around 9 kV DC. But all of our 77 tested parts passed the test for the whole 60 seconds. So that shows us really the performance and the quality of our products. Additionally, we performed the before mentioned partial discharge test. But there I will explain a little bit more on the next slide. A partial discharge test for signal transformers is a test that aims to measure the partial discharges which may occur in the transformer's isolation structure during the test. Partial discharges are electrical arcs that form surges between electrodes of any areas of the isolation media of a transformer between the conductors. These discharges may occur in air bubbles left in the isolation media, gaps in the solid materials, or at the surface of 2 different isolators. Also, if these discharges have small energy, the thermal energies due to the discharges can cause aging, deformation, and tear of the isolation material. Partial discharges is a failure process that starts small, always gets worse, and leads to flashovers. Therefore, fixed isolation in which partial discharges occur during operation is not permitted in the long term. This test is passed if the quantity of partial discharges is below a limit value of 10 picocoulomb. The test procedure is standardized, so as you can see in the picture on the right side, even a stricter test with 5 picocoulomb is passed. So at this point of the presentation, I would like to briefly mention also our website with our content module and many other useful tips and tricks. On this page, our product range for all BMS transformers are presented in tabular form, which are relevant technical data. You will also find further information on the products, the BMS area of application, the layout guidelines, sample applications and different working voltages, and a list of some frequently asked questions. For sure, you will also find additional documents and our datasheets for these components. You can also see and compare our available BMS transformers in our Red Expert. Just like the motto, more than you expect. So, let's come to the conclusion and the outlook. Let us conclude these presentations and the main topics out of it. In summary, it can be said that the high voltage BMS transformers play a major role in battery storage solutions. They work primarily as a safety component to achieve the galvanic isolation. The higher the working voltages, the greater the dangers and risks that can occur. It is therefore important to follow the standards and use such security components in the application. I hope I have been able to give you a good overview of the role of BMS transformers and show their importance. Due to the transition to renewable energies, there is currently no way around battery storage systems. The phasing out of nuclear power and planned shutdown of coal-fired power plants is particular, will further increase demands in order to guarantee a permanent and secure power supply. In the end, the future will show whether the results of the studies shown in the beginning of my presentations are accurate and how energy prices can be stabilized through the widespread use of battery storage in conjunction with the electric grid. Yeah, then I would say thank you very much for your attention. If you have any question, please feel free to ask. And I would be happy if you also visit our website afterwards, where, as I mentioned, you will find all of the range of our BMS transformers and further information in our content module.
So, thank you, Samuel, for the interesting presentation. Now we would come to your questions. Before we start with the Q&A, I would like to share you all the handout from the presentation. You can click on it and then you can download on the bottom on the right side. And then I would say we can start with the Q&A session with the first question. So, first question. Where do you see the advantages of high capacity battery storage systems that operate at voltages of up to 1500 volt compared to battery storage systems with lower voltages?
That's a good question. So, for example, we can say that that higher the working voltages are, that more energy can be stored and delivered. So we see that battery storage systems with higher working voltages can store more energy in a smaller package. So we see that in future, as the requirements are high, as you can see, we have a large opportunity to save battery or to operate it in such a power grid system or large industrial plants. We need a lot of power, and therefore it's good to have high working voltages to save more power in a suitable case.
Okay, cool. Thank you. Then we come to the next question. What future developments do you expect recharging battery management systems and transformer solutions?
Also, this is a good question. So, as you can see, I showed you some transformers for working voltages up to 1000 volt and also some for working voltages up to 1500 volt. And we see that the market is going on there to higher working voltages. And also the development of battery storage systems and the BMS is continuing over the next years. So we see maybe we have a trend to even higher voltages, and this maybe also continue in the future. So maybe we get like 2000 volt working voltage or something more. And yeah, also this is our job, to evaluate the market situation and then look if we maybe bring some more transformers with even higher working voltages, more up than 1500 volt. But I think for now we have a good planned portfolio, and also the 1500 volt will consist also some of the next years.
Okay, then we continue with the next question. Part 12, are you using, it means the Folie 12. Are you using some kind of coating material in the housing?
Yes, we use also some filling material in our housing.
Okay.
This can be also seen in our data sheets. So yeah, there is given some information on that.
Okay. Thank you. Then next question. So, the temp test of isolation is not taken in consideration in the humidity moisture factor. Do you have some kind of wet test in a high moisture to moisture environment? So,
yeah, okay, so the temp test of the isolation, so we see that our complete parts have a qualification. As you see, the AEC-Q 200, and then we perform some additional tests. So we have this temperature range from -40 to +125 degrees, also for longer time, like 1000 hours. And do we have some kind of wet tests in high moisture environment? We could do that. So sometimes we also make some additional tests. So if a customer has higher requirements or something like that, normally the insulation is also tested throughout the wire. And as we have some filling material in behind of the part, this is also normally we have no problem with high humidity or moisture factors.
Okay. Thank you. Then
maybe we have also the question for the standard number of the ICQ test for the partial discharge test. I would say this answer I will answer later on, so as I not have the standard now here, but yeah, it's a good question. So there is a norm of it. I have it on the computer, so I will just write it afterwards.
Okay, then I would say next question, this one. Science technology to handle high voltage is now at Würth. When can we expect simple inductors for buck converters with voltage rating higher than 400 volt?
That's a good question, but maybe I'm the wrong person to ask this question. So as we are just looking here on the signal transformers and especially on BMS application, I cannot answer for now how the colleagues for buck converters are working and what their plan is for the future. But maybe you can ask these questions to your ADM.
Okay, then I would say last question. Is it the lifetime of the transformer influenced by the actual working voltage?
No. So as we perform a lot of tests, we guarantee for a long time the lifetime of our transformers. And this is also for the application of the battery management systems. It should last a long time. So it's not good if it's breaking down in a few years. So we can see that, for the actual working voltages, we see no problems for the future. So we do a lot of tests, as you can see, and also our parts pass this test. And we think there is no problem and no big influence.
Okay, thank you. Then I would say we are finished with the session of the Digital V-Days. So if you have any more questions, you can write in the chat, and then Samuel will answer it then via email in the next days. So yeah, Samuel, thank you for your time. Thank you for the interesting presentation and also for the answers of the questions. And then I would say, then I would say it's the end of the session. Cool to have you here, and hopefully we see you on our next session of the Digital V-Days, and have a nice day, and bye-bye.
Yeah, have a nice day, have a good lunch, and see you soon.